All right, welcome to this explainer. If you're a truck tech, a diagnostic engineer, or a fleet maintenance specialist, you already know exactly how critical these systems are to keeping those Volvo FH and FM trucks on the road, and more importantly, out of a nasty 5-mile-per-hour D-rate. Today, we're going to take this highly complex system and break it down into clear, actionable steps that you can take straight to the workshop floor using VOCOM and Premium Tech Tool. Let's jump right in.
Here's our roadmap for today. We'll be hitting EAT's architecture and components, connecting VOCOM and PTT, evaluating DTCs and live data, forced regeneration and safety, and finally, post-repair verification.
Kicking things off with Section 1, EAT's architecture and components.
Think of the exhaust gas flow as a journey. It leaves that optimized diesel engine, passes first through the diesel oxidation catalyst and the diesel particulate filter, where all that soot gets trapped, and finally it flows right into the SCR catalyst. Understanding this linear progression is absolutely vital. Why? Because any failure upstream in the DPF is going to have a direct, undeniable impact on the performance and the sensor readings of the SCR downstream. It's like a domino effect. So this entire assembly is known as the Exhaust Aftertreatment System, or EATS for short. Its main job is pretty incredible, delivering near-zero emissions without completely tanking the engine's fuel economy or reliability. Basically, it handles two main bad guys. First, particulate matter, which is the physical soot and ash caught by the DPF. And second, nitrogen oxides, or NOx, which are neutralized by the Selective Catalytic Reduction, or SCR system. Now, check out these temperatures. We're talking about a massive amount of thermal energy here. The temperatures across the different exhaust sections are drastically different, with the outlet pipe hitting over 700 degrees Fahrenheit. That intense heat is what chemically alters the soot into a harmless gas in a rapid-fire process that takes just 10 to 12 minutes during a regen. Keep this extreme heat in the back of your mind, because it's a huge safety factor we're going to revisit in a few minutes. Working right alongside all that heat is the Regen, or DEF system. You've got the DEF tank, the pump unit, and the dosage valve, and they all work together to inject a really precise mixture of water and urea straight into the exhaust stream, right between the DPF and the SCR. Through the magic of heat and a catalyst, this system converts those harmful NOx emissions into harmless nitrogen and water vapor. Moving right along to Section 2, Connecting VOCOM and PTT.
Okay, so you've got two main ways to hook up your VOCOM 2 unit to the truck's diagnostic port. You can go the old-school traditional route with a direct USB connection using the ECTA12 cable, which honestly is rock solid when you're doing intensive module programming. Or you can use a wireless WLAN network running on either 2.4 or 5 gigahertz. That wireless option is fantastic when you need mobility around the shop floor to check physical components while keeping an eye on live data.
Quick heads up, if this is your very first time setting the hardware up, keep an eye on your Windows taskbar. When you plug the device in, Windows has to install the necessary drivers. Now, this can actually take several minutes because of Windows-specific configurations, so just be patient. Wait until you see that green Ready to Use icon pop up. Seriously, don't rush it, or you're going to risk dealing with annoying communication errors right out of the gate.
Once you're successfully connected, Premium Tech Tool's Guided Diagnostics is going to be your best friend. This is an absolute game changer for both intermediate and advanced techs. It gives you a structured, step-by-step path organized into logical tabs to help trace and solve active faults. But remember, PTT demands a systematic approach. All active codes must be investigated and actually corrected. You can't just clear them and hope for the best.
Let's dig into Section 3, Evaluating DTCs and Live Data.
Listen up, because this right here is going to save your shop a ton of time and money. Volvo specifically warns us, do not replace the NOx sensors if you pull codes P2208-1C or P220B-1C. Those codes are screaming that you have a power supply or wiring harness issue, not an internal sensor failure. If you instantly throw a brand new, highly expensive smart sensor at a wiring problem, you're not going to fix the truck. Always verify your circuit voltage first. On the flip side, if you see these specific codes pop up on your PTT screen, that's a huge red flag for potential physical damage to your inlet NOx sensor. We're talking Bank 1, Sensor 1. If you're getting codes for unexpected fuel injection quantities or stuck performance signals, that sensor might actually be compromised. But hey, even with these codes present, don't just unbolt it yet. You still need to verify its condition through active software testing. So how do we verify? You're going to run the NOx conversion test right inside PTT. And here is the golden rule for this specific test. If the outlet sensor
that's NOx 2, fails the evaluation, you replace the outlet sensor only. Simple enough, right? But if the inlet sensor fails the test, you actually have to disregard the results. Why? Well, remember the exhaust flow we talked about? The SCR is the very last component in the chain, which makes it super susceptible to upstream failures. An inlet sensor failure often points to a much larger combustion or DPF issue that you need to address first.
All right, Section 4, Forced Regeneration and Safety.
We've got to talk safety, and this is an absolute zero-tolerance rule in the shop. Never, ever use ether starting fluid, and never operate the truck in an area where there's a concentration of hydrocarbon vapors, like gasoline fumes. Remember that 700-degree heat we talked about? The extreme heat generated in the DPF during a regen can actually draw those vapors right in and cause a massive, catastrophic explosion. Safety first, no exceptions.
To do a forced regen safely and effectively, you've got to follow these 5 steps to the letter. First, get that truck outdoors, or into a really well-ventilated bay. Second, check your engine coolant. It needs to be right in that Goldilocks zone of 160 to 190 degrees Fahrenheit. Too cold, and the regen just won't initiate properly. Then, you connect your VOCOM, navigate through PTT to find the regen command, and kick off the process.
Once it kicks off, just sit back and keep a close eye on the live data on your laptop. A normal, healthy regeneration is going to take about 20 to 30 minutes. And listen to me on this, under absolutely no circumstances should you interrupt this process once it starts. Hitting stop midway through a forced regen can cause severe system issues, leave soot partially baked inside the filter, and completely scramble your control module parameters. Just let it do its thing.
And finally, Section 5, Post-Repair Verification.
This is the phase where you need to spot the difference between an electrical lie and a physical reality. For instance, a faulty DPF differential pressure sensor lying to the ECM will cause failed regens, it'll mess up your DEF dosing, and bam, the truck goes into a 5 MPD rate. However, if your soot level stays completely pegged at 100%, even after you've tried to regen it, you're dealing with an actual physical blocked filter. That means taking the DPF off the truck and using special equipment to professionally clean all that accumulated ash out of the substrate.
Look, even after you swap out a bad sensor or bolt on a freshly clean DPF, you are not done yet. You have to perform these final software steps to close the loop. Clear out those inactive codes, reset the learned engine parameters in PTT, run one last forced regen to absolutely prove the system is clear, and finally perform an SCR efficiency test. It's literally the only way to satisfy the engine control module and turn off those super annoying check engine inducement lamps for good.
So I want to leave you with a thought to take back to the shop floor. When that Volvo rolls into your bay, are you just plugging in, clearing the codes, and crossing your fingers? Or are you really digging into PTT, understanding the live data, and truly verifying the after-treatment efficiency? Always make sure you're treating the root disease in the eats, and not just slapping a Band-Aid on the symptoms. Thanks for joining me on this explainer, and I'll catch you on the next one.